Hello, everyone. Welcome to the 200th episode of the Day Zero podcast. Pretty big milestone for us. A little hard to believe we've been going for this long. So, yeah, today we have binary topics. And yeah, so we've been running for about 139 weeks, 78 episodes total in our old monolithic format, and 122 since we split into bounty and binary episodes. It's kind of funny because we can use the release date of Ghidra as our touchstone a little bit, as our first ever episode actually centered heavily around Ghidra's release. That episode was March 12th of 2019. So, yeah, at this point, we've been doing the Day Zero podcast for a little over 4 years. Like I said, it's hard to believe that it's been that long. Z also has some other fun stats I'll let him get into, but before that, we'll cover the Spot the Vuln solution. So I'll pass it over to you, Z.
In this week's Spot the Vuln, hopefully relatively easy to spot for most of you. Race condition here in the shopping cart. Patching it gets a little bit tricky, but talk about the code quickly here. I've got just a random class here, shopping cart, with this redeem coupon, returns whatever the discount for that coupon would be, or 0 if it's nothing. And then I've got the app route checkout, so the checkout endpoint, post to it. Whatever else is going on there, it can get the cart for the session, and it will take the cart and redeem coupon. I guess I do have a typo in that code. That should be cart, not shopping cart. So it's accessing the wrong variable. Nonetheless, you get the logic here. It's accessing the cart and figuring out the discount. And in this redeem coupon code, where it's trying to figure out the discount, it'll do a query to select the code, whatever you've entered. And it'll do that with redeemed equals 0 to make sure it has not yet been redeemed by anybody, assuming, all these coupons can only be used once. If it can't find the coupon, so it's either been redeemed or the code doesn't exist, return 0. Otherwise, it'll run the update query and then return whatever the float version of the discount would have been. So in theory, it all makes sense. With the race condition, you could have multiple users providing the same coupon code, and so in theory, you could have multiple users, or one attacker, multiple shopping requests, and multiple accounts, or multiple cards at least. They would be able to take that, have multiple things pass this first query, where it's redeemable equals 0, and get past that, and then have several try and update the value to redeemed equals 1, say it's redeemed, and then return from the query. So you'd have multiple coming through, getting the discount, despite only technically being able to redeem it once, just by having a bunch of requests come in all at the same time. Some are bound to kind of flow through that. Fixing it is a little bit interesting. Ideally, try and just avoid structuring it in this way to begin with. But if you're not too scaled, like if it's a small application, you can just use locking in the application. You could also do database level locking, which is, if your database supports it, probably the smartest place to do this. You can lock either the row or the entire table. It is not very performant when you lock the entire table. But doing the locking, making sure you can get the lock and all of that, and with the appropriate value, would be ideal in this case. But without that, you could try and do a double checked sort of situation, except that there's going to be a race and update it with a unique code that represents a UUID or something. And then wait some period of time for database consistency reasons, make sure all the writes have happened, and then read it again to see who actually won the race. And that's when you would continue. Not the best solution, but it is something that would work if your database doesn't actually support locking. It is hard when you try and scale this to prevent this sort of race from happening. So it does get a little bit tricky, but yeah, ultimately the vulnerability here is just that race condition on redeeming a coupon.
Cool. Yeah, we like to see those race conditions in web. It's pretty rare that we get to see them. The one that always comes into my mind when we have these, when we see these classes of issues, is the CTF points update, which we covered years ago at this point. But yeah, so Z, I know you collated some stats on the history of the podcast and such. So I'll let you get into that. There's also a blog post for it for anyone that's interested in reading it afterwards. But yeah, I'll let you go into some of those.
Yeah, I guess you already hit kind of the length and stuff. I've got some stats here about things like our longest episode being 2 hours and 40 minutes long, which, back during our first while, we did do some pretty long episodes. We had several going more than 2.5 hours.
Preparing
Yeah,
for those was a full day job. It was pretty
yeah,
brutal at that point.
it would take a while. And one of these episodes, not even our longest, but on episode 18, we had 22 different topics covered during it. And on the flip side of that, we've actually had one episode here that was just 22 minutes long. That's after we kind of split up into our bounty and binary episodes. Uh, but it wasn't even our shortest episode, episode 126. We only had 3 topics in it, but managed to go for 47 minutes during that. Um,
Yeah, it's funny because that, like, as we went on, right, and we started covering more and more topics that had a lot of overlap with previous topics. Of course, the coverage got shorter, right? Where it's like we don't want to iterate or reiterate a ton for people who have been listening for a while. It would become really annoying. So it's kind of funny to think about how that evolution happened. Some of the earlier episodes, we also covered a lot more like academia stuff, a lot of white papers, which some of them were interesting at the time, but we started noticing a trend where it was like a lot of them were kind of ending up in the same dead place, hitting sort of the same notes, and we kind of started dropping the white papers as time went on. We still sometimes cover them every now and again, but at one point we were covering like 2 or 3 an episode,
yeah, at one
which,
point
yeah.
we had a lot of fuzzing papers that were ultimately just like add symbolic execution to this fuzzer in some place, and we've got a new fuzzing paper. Like, you had a lot of those kind of cookie cutter fuzzing papers. So I've tried to be a bit more selective. And actually, while I was getting all of these stats, I noticed it was right around the start of COVID where we had that shift, where we stopped with the having quite so many papers. Um, and kind of moved more. So we also used to cover a little bit more news, a little bit more of the like breaches happening or something like that, where we had a Vuln week talk about a breach following it. A little bit more on the thread until we kind of started dropping those topics around the beginning of 2020. It was a little bit before COVID, but around there is where we kind of broke off and I think really started focusing in on just the vulnerability reports as we do with most of our episodes now.
Yeah, and a bit of the
Um,
background there for those of you who have been with us for a really long time might remember that Auntie was joining us back then too, who was very like in the loop on the threat intel sphere, whereas Z and I aren't. So that was a big reason why we started dropping those topics, was just because we didn't really have much to say on them because we're not really in that sphere. Um, but
yeah,
yeah.
and XCD80 asks, we aren't counting the time you guys watch Toxicons. Yeah, I don't really count those as part of the podcast. Those are just our discussions or whatever. It's not really the podcast. So yeah, I'm not counting that. The only discussion that really makes it in here was when we had Bastian Gruber on episode 99. We were talking about Rust. There was a 45-minute discussion about Rust on that episode. Uh, and that was actually, I think, our longest. Yeah, that was our longest topic, kind of in general. But when it comes to vulnerabilities, I did figure out that we spent 33 minutes poorly covering the micro-architectural data sampling attacks, the MDS attacks, back when those came out, back on episode 10. I can't say I did a good job of covering that, but I gave it a shot during that episode for, half hour. So those were kind of low level, fairly low level vulnerability, or like hardware level vulnerabilities.
And I
Um,
think at the time we really didn't have a lot of experience at the like that low level. I think since then we've both gained quite a bit of experience, and I wonder like if we went back to try to cover that topic, if we could do uh, a much better job now. I feel like we probably could.
I feel like we have
Um,
more insight, especially after, because there were, so we had the original MDS attacks and zombie, and for like the next year or so, we had several kind of similar attacks coming out, so we were able to gain a lot more of that background and foundation on those topics. and kind of
Yeah.
cover how they worked a little bit better.
Yeah. And that's one thing that's been nice with doing the podcast too, is like not only do we get to cover topics for those who find, the show interesting and whatnot, but it also has kind of helped us, or me especially, fill some gaps. Because there was a lot of stuff before the podcast where I wasn't really uh informed on it, or like I just didn't really take too much of an interest in it. I didn't go out of my way to look into those sorts of topics. So I had more knowledge gaps back then than I do now. The podcast has been a nice opportunity for that as well.
Yeah,
Um,
same for me, being able to kind of fill in some of those gaps and just spending time doing a bit more research that I maybe wouldn't have otherwise.
yeah, and Rudimal just made me think of something. He said, "Yeah, those were fun. Wonder if we can get some more guest episodes." We have had a few, not a ton, but Bash and Gruber. We also had CTS on for one or two for fuzzing related topics. It might be nice to pull out some of the episodes that did have guests on them. Um, yeah, that might be like a nice list to put together as well. I don't think that's in your post.
No, it's not.
I
I think
only
it's
glanced at.
really only the Rust topic, and then when we had CTS on,
Yeah, but
I
though I
don't
think we had him on a
think
few times.
we've had him on twice. I don't,
Yeah,
but it's just those 3 episodes.
yeah,
We did have
um,
one episode where you weren't even on. Episode 112 was just me going solo.
yeah. That was a really rough day for me. Because I think I was like really sick at that time.
Yeah,
Um, yeah, so
but yeah,
there's been some interesting history with the podcast overall, and seeing like the evolution of the topics that we cover and such.
yeah, and I kind of went back over everything, was categorizing it because I wanted to figure out how many vulnerabilities we've actually covered. I don't have that number, but I can say that with the end of this episode, we'll have covered 1,125. I have the wrong number in here because we added one topic to this episode, but yeah, over 1,100 different vulnerability disclosures. So more than that in terms of vulns, because sometimes we have multiple vulnerabilities, but we've talked about a lot of bugs.
For
And
sure.
even just our summaries, where over 450 vulnerability summaries written up there.
Yeah, and you can kind of see that in the the site list that you have constructed there too, with a lot of episodes containing links to HackerOne and Project Zero, the Project Zero bug tracker, things like that. So yeah,
Or hacker INE, I guess, because I typed that wrong too. But yeah, actually, I do want to shout out really quickly though. The top list for a place that we got our topics from, more or less what you'd expect. HackerOne, of course, they've been on a ton of episodes because that's like a huge part of the industry. ZDI, Project Zero, and their bug tracker. If we combined Project Zero and their bug tracker, they uh just doing the mental math here actually would have been
they
number
would top the
one, but I do
list.
have them
Yep.
separate. Uh, but yeah, I do want to call it the individuals though. Some, well, a lot of these top 10 are all corporations, all putting out a ton of research. We did cover Yusuf Samoda, his blog. We've covered across 8 different episodes, and that's kind of our top individual publishers made it out on this one. And David Schultz with 7 episodes and 7 topics. And then we had a few people here, uh, Julian Kretel, Alex Popov, and Maxwell Dolan, having 4 topics on 4 episodes. So I thought it was interesting to look and see just how many topics we've covered, but then how few have kind of been covered multiple times and have kind of consistently put out interesting content.
Interesting to us at least. Yeah.
Yeah.
Yeah, it's kind of neat to see.
Yeah, because we've had like 750 different domains covered on this, but only about 200 of them actually kind of repeat.
Yeah. So yeah, like I said, it's been a while. Thanks to everyone who's been with us for a while now, and yeah, it's pretty cool to hit 200 episodes. Even though I guess we did sort of cheat when we started splitting the podcast a bit, but we'll just pretend that doesn't matter.
I
So
mean, we could have done this as our 4-year marker too.
yeah, that's true. Yeah,
Because that was
because
2 weeks ago.
yeah. All right, so getting into some topics, we'll start off with Pwn to Own. So Pwn to Own Vancouver just concluded at CanSec West last week. It's a 3-day event. Synactive ended up taking the cake at first place with 53 points, which is quite a large margin compared to second place at 19.5 points by Star Labs, followed by Team Vietel, Curious Security, and Abdulaziz Harari. Various targets were popped here, including Windows 11, Ubuntu, and Mac OS. Though Ubuntu had quite a bit of collision, and it's actually some of the meta stuff I wanted to talk about a bit more here than the results, which kind of feeds into Ubuntu having the collision that I just mentioned. It seems this year that Pwn2Own changed their rules for their events with regards to the local escalation category. I'm just going to bring up the announcement for Pwn2Own to get into that, because that's where they talk about it a little bit more. So in the announcement, in local escalations, that covers Ubuntu Desktop, Microsoft Windows 11, and Apple macOS. They state that you have to leverage a kernel vulnerability now to escalate privileges, which is pretty significant because previously Ubuntu LPEs and other operating systems, I believe, you could target things like set UID binaries and the like for privilege escalations. And it seems like Pwn2Own kind of deemed that to be too easy or too soft of a target. So for this event, they required you to leverage kernel vuln, which is raising the bar of entry a decent bit. So I'm sure that limiting the attack surface contributed a lot to that collision. And it's interesting because I've seen thoughts on both sides, both before and after the event. Some people were really not happy with it, saying like, it's almost comes off as like, screw it, we give up on Ubuntu security and just care about the kernel. And it sort of shafts researchers who were looking more on the user space side. But on the other hand, though, there is something to be said for taking advantage of these meme type bugs, and the more critical ones being skipped over since they're not the path of least resistance. So there's kind of, you have these arguments on both sides that have a little bit of merit to them. If I had to come down on one side or the other, I think it is fair for them to restrict the scope down and only accept kernel vulnerabilities. Maybe I am a bit biased there because I do kernel research primarily, but like when we've seen some of the vulnerabilities that have came out of these set UID binaries and the amount of like crap that Ubuntu shoves into their user space, it's I can understand why they would want to stop paying out for that. The attack surface in the scope was just pretty large at that point. So
You know
yeah,
offhand if Ubuntu has like just a normal bug bounty? So I think the key thing with Pwn2Own is the fact that they are giving a pretty significant payout here. And so with that, I kind of understand them wanting to limit it to just the kernel bugs, just something that they're kind of hardening a bit more. Recognizing, I imagine they recognize that like those UID binaries are a huge security problem and some they do need to deal with, but also probably not the type of bugs that they want to spend $30,000 on every one of them. Like, it's not worth that when they're kind of aware of the core issues versus having the kernel findings. So it kind of sucks for the researcher side, but from a company side, you kind of have to be willing to admit sometimes that you're not ready for a bug bounty on X area. It's just not worthwhile to do that. It's just part of the maturity process of, first you do the VDP, you give people a way to disclose them, and only after you have like your regular testing, regular pen tests and auditing and all of that, then you implement the bug bounty. I know some bug bounty hunters don't entirely agree with me on that, but that's generally the maturity process I see. So if they're noticing like this area is problematic, we know that, we need to deal with this, I think it's fair to do that rather than just completely pulling out. Because I think that would be the other option. It's not necessarily a choice between does Ubuntu desktop pay out for kernel vulnerabilities or kernel vulnerabilities and SecUID vulnerabilities. If it wasn't feasible, it would really be between do they pay out or do they just drop from the competition altogether, and I would rather see them stay in.
that's fair. You were asking earlier if I knew of any bounties for Ubuntu, right?
Yeah, if you knew offhand if they ran a bug bounty program in particular.
Yeah, so I don't think Ubuntu like Canonical does. I know like ZDI will submit submissions for stuff like that. We've seen some of them before. The thing that I was trying to look up and I couldn't really find quickly was I know there's an organization like the Open Source Security Foundation or whatever it is. I forget the exact name. I'm wondering if they paid out for Ubuntu issues. I know they paid out for like Linux kernel issues, but I don't know if they'd pay out for like Ubuntu user space. I was trying to see if I could find their like scope and whatnot, but I couldn't find it because I don't even remember the precise name of the organization. But there are some avenues where you could get paid out for uh Ubuntu vulnerabilities, um, but not directly by Canonical, and I don't think you really get a lot of like nearly as much as you would have gotten at a Pwn to own for them. So
No, and I
yeah,
mean, Pwn to own is kind of special on that front. They do up some of the bounties just in general here too, even if they were paying out elsewhere. So yeah, I mean, I just tried looking it up. I found some information about like Canonical having a VDP, a vulnerability disclosure program, but not specifically about a bug bounty. So
yeah, I
yeah,
knew they had like some bug trackers and stuff like that, but yeah, I don't think they have a proper bounty. So yeah, I mean, in regards to ZDI and Pwn to own, it'll be interesting to see if they continue with this course, and if like the future Pwn to owns will also have this ruling with local privilege escalations, or if they walk that back. Because I know there has been some backlash on it from some of the prominent researchers that have submitted to Pwn to own before, so they might end up walking that back or changing something towards something like what you were saying. But yeah, only time will tell that. But I thought it was worth bringing up because it is kind of an interesting rule change uh,
it
that
is because
does have some impact, especially considering some of the submissions we've seen in the past.
yeah, like it does feel cheap to be like, yeah, Ubuntu desktop, but only this part of Ubuntu desktop.
Yeah,
So like it does feel cheap at the same time. Actually, I guess I'm not sure exactly how the maintenance works when it comes to Ubuntu. What my comment was going to be was Ubuntu also isn't really the ones in charge of all of those binaries. They just kind of collate them and put it all together. But actually, I'm not sure what their maintenance policy is and how much ownership the people in charge of like that package actually have in their relationship to Ubuntu versus whoever maintains the core program itself. Because it can also just be the case of like they don't want to pay for vulnerabilities that aren't under their control, but then they're not exactly the kernel either. Part of what they do is providing all those other binaries, so then it makes sense to put the blame towards them. I don't know. There's complexities here. I can kind of agree with both sides, but I do kind of lean towards preferring that they stay in with the kernel limitation than just completely walk away if that were the only other option.
yeah, I think that's fair. And like I said, I can kind of see both sides and see why it'd be frustrating for those researchers. And yeah, like TLDR, like user space just gets a lot more complicated than kernel because it's not as like kernel is pretty centralized, whereas user space is very much decentralized. So uh,
And
it
a lot
gets
more
more
attack
tricky.
surface.
That as well. Yeah. All right. So getting away from Pwn to own, we have a Talos vulnerability report on an integer conversion bug in some ICS or industrial control system stuff. Z, I'll let you get into that.
Yep, an ICS intended for I think they say here, yeah, designed to be high performance and high reliability, but probably not high security in this case. And it is very, it feels very much like a meme bug. Within the RecvPacket functionality, uh, there's a pretty straightforward buffer overflow. What does it check some flags? Flags come in. They don't talk about what the flags actually mean. Just that one of the bits indicates how large the size field is going to be inside the packet. Either it'll be, if the bit isn't set, it's going to just be a 1 byte long size, or if it is set, it's a 32-bit or 4 byte long. Uh, does a little bit of bit magic to pull out the packet data. Pulls out when it's a 4 byte size, pulls out those 4 bytes, does a comparison with that. And the problem is that with that comparison, it does so using a signed value, or it does a signed comparison. So if you provide something greater than the hex 8 000s on there, so the highest negative value, the lowest kind of, it's where the negative value, it's where it flips. If you're familiar with these sorts of attacks, you know why that value matters. And I feel like we've talked about that on a variety of episodes. So provided a high enough number so it goes negative, that's check will pass, but the buffer it's copying into is just 64,000 bytes. So copies in way too many bytes into a 64,000 byte long buffer, and you get an overflow on the stack. Straightforward, and high performance, not high security. But yeah, they do kind of reference here that a multitude of bugs will occur, and just the one instance is at this size. Once extracted, is used directly as a mem copy. Presumably, there are other things here that they just don't go into. Sounds like there's just a ton of problems.
Yeah, I got a bit of a laugh when I read over this post, especially because most of the time when we cover these sort of black box or gray box attacks, they'll post the decompilation or some reverse code. Here, it's just the disassembly, and they kind of comment on what's relevant. And they have that comment above the JG instruction, which shows you like the signed compare. And it's like exactly what our Spot the Vuln challenge was a few weeks ago, and one of the OG ones. It's kind of funny how much it bears a resemblance to that challenge, because it is like essentially the same issue. So
Yeah, and these signed issues really kind of stand out a lot more when you're reading the assembly than when you're reading just source code.
yeah, because you see the ultimate type inferencing there. You don't have the layers of potential like type inheritance and whatever to comb through and source from a source level view.
Yeah, I mean, although as we've mentioned before, there is binary ninja kind of documents what type comparison is happening, which is pretty useful. But other than
Yeah,
that, you kind of need to think through it a bit in order to figure. Or does
you have to pay
IDA
close
like you
attention to the
hover? I
types.
think I'd have to double check. I think IDA, when you decompile, you might be able to hover and see if it's signed or not. So like it's there, but it takes a bit more effort.
Yeah. And Rudimal says spot the JG. Yeah, that's pretty much what it is. So, like you said, it's kind of a mean bug. These types of integer conversion bugs typically are, and we're talking about industrial control systems, so it's kind of a given, I suppose.
Yeah, you don't have high expectations there because there is a bit of a high ask to actually get into position to provide these packets. Assuming it's not just wide on the internet, which usually they're not, but there have been cases of these sorts of systems being out there. Malware Guy mentions assemblies as raw as you can go, and that's true, but that actually makes it harder to spot a lot of vulnerabilities. A lot of vulnerabilities, when you have the context of what variables are being used and how the flow kind of happens at higher level perspective, it's a lot easier to spot than just looking at the assembly, noticing it. This is one of those vulnerabilities that is easier to spot in assembly than with actual code.
Yeah. All right. So
Or
getting
you test
into a
it.
yeah.
Dynamic testing is, a very viable way of finding something like this too.
Yeah, this is a very like fuzzable bug, I would say. So yeah, getting into a slightly more interesting exploit chain. There was a post by Thallium on uh, exploiting ARM TrustZone and compromising the trusted execution environment of Samsung devices. Um, that trusted OS is known as Tigris, and it's a pretty cool post that goes into a good bit of background on TEE and where it's used and whatnot. Ultimately, there's two vulnerabilities here. Goes through the you know architecture basically. For those not familiar with TrustZone, you have two sort of worlds, as they call them. You have the normal world or non-secure world, and you have secure world. Your more typical operating system like Linux or the Android OS is going to be running in a normal world, and then for doing security critical actions or things like Nox or whatever, it's going to communicate through EL3 or the secure monitor to talk to the secure world where trustlet apps can be running and stuff like that. So you know secure world is pretty high up the chain of trust. It's not something you can generally jump to right away, but it is kind of an interesting target because it is where the more sensitive things live. That's the whole point of doing this sort of isolation.
Yeah, like
And it's also
there's a pretty substantial kind of barrier to kind of understanding how to do all the communication, kind of getting to the point of speaking with and testing these applications that I think holds back the security because they get away with a bunch of dumb stuff because not many people are actually testing it.
That as well. It's typically more closed source, or it's just not as well understood, so it's not as audited or reviewed. So, and you'll kind of see that with the kinds of issues that are discovered here. So they go into some detail on how the normal world talks to the secure world. That's not like super relevant, but it it's there if you're interested. It talks about like the secure monitor calls and stuff like that, and the trusted apps that it has. They just seem to be in like decrypted files on the file system that get loaded in ARM32. And yeah, so the first issue that they found was in the key MST trustlet um, for like key management, and there it was kind of a classic Stack Overflow when they were importing RSA key public exponents. RSA keys are, I guess, some of the more trickier, structured crypto to handle because you have so many components of it. The exponent size isn't necessarily like known or like fixed as well as like a key size is, so it's a little bit tricky to deal with here. They just don't seem to validate the the exponent size, and so they have sort of a classic Stack Overflow. um they
Well,
can
so
overwrite up to hex 200 or hex 1f8 bytes on the stack, I guess, because of um the inline size. But yeah,
there
go ahead,
is
Z.
there is a little bit of checking going on, which I think is kind of funny. So they read this value, the exponent size, into a 64-bit integer. They do actually have a check earlier on that checks if it's less than 512 bytes. You've got quite a bit of room to overflow there with, but yeah, I think it's fine that you've got that desync in the checks between one side trading at 64 bits, the other one, oh yeah, this can be up to 512. Like, very different values here.
Yeah, yeah, just really weird checking. um yeah, beyond that, getting into the second vulnerability, which they use to escalate to the secure kernel, they talk a little bit about the logging driver. From there, this seems like something that's potentially maybe intended. I'm not really sure, but basically, the logging driver allows you to pass in a format string, which it'll use for a printf, and that creates a format string type issue because as an attacker, you can just control that to be able to get like an arbitrary write primitive. It is a little bit limited because you can see in the log message functionality here, you don't really control the arguments that are going in. You just kind of control that format string. But you can exploit it multiple times, and it's you know you've you've probably seen this kind of exploitation before if you've looked at format string bugs. It's sort of like a CTF type scenario where they just use it multiple times to build up a payload for you know getting code execution. So nothing too crazy there, but it is kind of interesting just because of the area that it's in, where you are talking about the secure world and popping the secure kernel. Could be very useful in certain situations. Samsung and Huawei are kind of the two big players in the Android space that use this kind of trusted execution technology. Maybe we'll start seeing it in more devices as time goes on. I'm not sure, but Huawei and Samsung are the big ones, and here they're looking at Samsung. Um, yeah, it's just a cool post. There's some cool information here. I do recommend checking it out, especially if this sounds interesting to you. I did skip over a good bit of the background on how the secure world works and some of the specifics there,
Yeah,
but that is there for you to read.
there was some interesting stuff here about how they actually did kind of stuff the exploration or playing around here, building off like a little emulator using a. I'm not sure what the proper pronunciation of the tool is, but I usually mentally say Qiling.
I say Keeling.
QI.
Yeah.
Yeah, because I think that QI said Chi. So I do that, but QILING, which is a tool I've been playing around with a little bit lately, tool, and uh, has it's interesting. I'll put it that way. Just as kind of scripting off, it works off of Unicorn. If you're familiar with Unicorn Engine CPU emulator, works off that, adds in a layer of like actually parsing elves, parsing binaries, and has like loader. Starts supporting LON, all Python scriptable, which makes it a pretty interesting tool. So I also appreciate kind of seeing them talk a bit about using that as part of their process here.
All right, so continuing on memory corruption and some mitigation, getting onto some defensive and mitigation side. Um, there was some slides put out by Theo de Rot of OpenBSD on synthetic memory protections, talking mostly about mitigating ROP through things like exotext or execute only text. Z, I'll let you cover this one, and then I'll jump in on the exotext stuff a bit later.
All right, yeah. So there were kind of 4 mitigations here. It sounds like basically they've implemented these. I'm not sure if they've landed in OpenBSD or if they've just like been implemented. I'm not sure on the process of them. But this does talk about 4 separate mitigations intended to make ROP more difficult. And I think we'll probably talk a little bit later on whether or not that's an effective route to go about on mitigations. But what they've done is they've introduced one being immutable mapping. So you have your memory mapping. You can mark something as immutable, so then the RWX or read write execute permissions can't be changed on that mapping any further. You can't like unmap and remap it with new permissions. It is immutable. I'm actually like, because you could use a ROP chain, and you can just create a new mapping, and you can do that and create a new executable mapping. So I'm actually not sure what attack they're trying to stop with this particular mitigation. It kind of underlies some of their other working though, so perhaps they're just introducing it as its own, but on its own, like, there's probably some attack that I'm just not thinking of that would actually kind of abuse being able to remap that, but it doesn't feel like the most common scenario or a really common issue that you're going to run into all that much where you actually want to just change the mapping of something. And they don't implement this on everything. Like, not everything is immutable, just a few select ones. So, I don't know, feels a little bit weird calling this one the ROP, but there's probably something I'm just missing out of this. The second mitigation that they introduced was execute only memory. Basic idea there, you have a mapping, you can say this is executable, but you can't read it, you can't write it, so CPU tries to read it should fault. Tries to write, of course, it should fault. You can just execute it. The main thing that's there to prevent are kind of your blind ROP attacks where it's there to prevent any of those cases. I get not always blind ROP, actually. But any case where you don't have access to the original binaries, you can't like run ROPR or something on to find your gadgets. And instead, how you would deal with that normally is find an information disclosure, use that disclosure to dump the memory, and then you can kind of find your gadgets. Another option there is like trying to brute force your gadgets, which is kind of still what you'd have to do in this case, but a more common, or at least an easier thing, would be to try and dump the memory and find your gadgets out of memory once you've dumped the entire memory space. Executable only memory prevents that. Doesn't really have much impact if you have the binary, like that source binary. Because if you have that, you can run ROP or whatever you use to find your gadgets on that file. You can do whatever analysis you want there. So like, again, it has an impact, but only in particular situations. Third mitigation was stack protection. All it really does, it prevents stack pivots. So every time, I believe it's when you make a syscall, the kernel will go ahead and check if the current stack pointer is still pointing to the memory mapping that was actually created for the stack. If it's not, it just kills the program. So effectively, you can't ROP, or you can't pivot your ROP chain onto like the heap. Like you can pivot it somewhere else on the stack, maybe, but can't put it onto the heap or anywhere else in memory. Last one here was their execute syscall protection. The way that one goes, similar, when you make a syscall, it will check the program counter or the instruction pointer, make sure that that is pointing to a page that it expects syscalls to come from. The main thing that's going to prevent is if you're taking, if your ROP chain, so kind of a common technique on Windows is to basically create a new mapping, give it like RWX permissions, and dump your shellcode in there and jump to it to execute it. So this would prevent that because your shellcode that you dump in there, in this new region, well, it could execute, couldn't make any syscalls because the syscalls are all making sure like only these regions like libc can actually make syscalls. So basically forces you into using syscall gadgets, as is relatively common on like Windows, and I want to say you do the same thing on OpenBSD, but I haven't written any OpenBSD exploits, but I don't feel like that idea of dumping is really all that common. I've seen more exploits that just use a syscall gadget in the first place, unless they just don't have that option. So yeah, that's kind of the four of them there. They do have one on the execute only memory. They do have one kind of odd thing, which was a kernel enforced one, which I don't entirely understand its point. It's basically for execute only. They call it X only. I prefer XOM, so but anyway, they call it this kernel copy in X only for code regions. And Spectre and I were kind of discussing this before the episode a little bit, where it seems like it won't prevent the cases where you have like an information disclosure and can read, because that doesn't pass through the kernel at all. That's a pure like user land CPU read. But it does prevent the kernel from copying in the unreadable memory addresses. So
Yeah. So basically, what I think they're trying to prevent there is there's a lot of bioctals that you'll have in the kernel, or any other mechanism, but ioctl is the immediate one that comes to mind, where you'll copy in a data structure and then it'll do some processing and copy that data structure back out to you. There's also some certain gadgets you can make where there's no processing done and you just get like a pass through. So what I'm assuming they're trying to do there is prevent you from abusing the kernel copy in API for copying in data, letting the kernel be able to read it, put it in a region you can read, and then use that as sort of like a side door to be able to bypass execute only the execute only mitigation. I think that's what they're talking about there, because well, it's the only
think
thing
you're
that really
right.
makes sense.
Yeah, like I can't, like, that is about the only, well, I mean, I couldn't even think of that as being why they were trying to do this, but yeah, um, I could see that being it. The only thing that they do mention this blocks BROP, which is the hacking blind, so I believe with that they're referring to hacking blind the paper, which is where that was like I think 2016, where blind ROP was introduced. But I think with that they talk about using a userland read to dump the memory, in which case it wouldn't really block that. I could be mistaken about that. It has been a while since I've read it. But I mean I would still consider using like that kernel, or using that kernel trick to be fair and like call that blind ROP. But like it feels like there are some versions of blind ROP that would not be stopped by this. So just kind of universally saying this blocks blind ROP feels a little bit off.
I think they're overselling execute only memory protection here.
Yeah, like,
um
and this is specifically just this kernel enforced one. Like the hardware enforced does have, or is a lot stronger. There are still ways to deal with that. I kind of alluded to the idea of brute forcing your gadgets. That is something you could still potentially do, but it can be problematic, or it can be challenging to do that. But you could go that route still with XOM.
yeah.
Uh, but yeah, I was also surprised they did get AMD 64 support. I just wasn't aware that that was kind of something you could do with the newer AMDs, but I'm not surprised given kind of where things have been progressing to.
Yeah. So on the execute only, like I think execute only probably is the most interesting mitigation of all of these. Because the other ones, like in my PS4, like I'll call them console mitigations because they're the kind of things that I've seen in like the PS4 and stuff. And really they're not really mitigations. Because like let me go through some of the other ones. So the immutable mappings, like you said, you're not always going to get in that situation. It might prevent you from easily getting, shellcode execution and keep you in ROP, but like that's not really doing very much.
But it doesn't even
Um,
do that. Like the immutable mappings one doesn't even prevent you from creating a new mapping that's executable.
yeah, that's true. So
The
yeah,
X,
that one
sorry,
just seems kind of useless to me.
the one does prevent you from doing that. That's the execute syscall protection. That kind of blocks you from doing it, but
Not really.
um,
Because I was just going to get to that one,
go
and
for it.
the execute syscall protection, all that really means is that you have to use like the wrappers that are available. So you'd
Yeah,
have to like use drop gadgets or something, which it could be nice if you want to do some sandboxing. Although if you're doing sandboxing assist calls, ideally you use something stronger and more built into the system, like uh, eBPF filters is one example, but there's others as well, like SE Linux and stuff like that. But you can do some, I guess, sandboxing with, like, if there's not a wrapper for a syscall, you can't use it. But really, all it's doing is forcing you into using those wrappers. Similarly, with the stack protection stuff, sure, you might not be able to pivot directly to the heap, but you can use QWERTY's iOS trick where you just create, empty stack frames and put your ROP chain there and pivot within the stack. Like
Yeah,
it's
like
it's not
most
really doing very
exploits.
much.
Yeah. Sorry, I keep interrupting you this episode, but yeah, like
No
most
worries.
exploits you uh can get away without being a stack pivot. Like it is kind of nice to have that. Uh but jumping back slightly on the execute syscall protections, like yeah, I was kind of saying that when I was describing it. You can get around it by using the existing gadgets, and I believe I didn't have a chance to confirm this exactly, but I believe Windows has had this for like forever. They've kind of been forced that. Part of that just being the consistency. They do change their syscall number, so you can't do the low level. You have to go through the functions. Um, but I think at least like maybe it was part of EMET, so it's the enhanced mitigation whatever toolbox thing. So maybe it's not quite there anymore. I believe though they've had that sort of thing for a while, and obviously people are still running exploits on Windows without much problem. It doesn't really add a ton.
Yeah, so I think those other three mitigations that are mentioned really don't do very much. They're pretty easy to get around, and in some cases are already like not really relevant at this point anyway. Getting into the execute only, that could be impactful in certain environments, like you were saying earlier. Again, I kind of throw it into the console mitigation category or like IoT, because in many cases you are going to have the binaries and you can just search them or reverse them anyway. The only scenarios where you're really being blocked off from getting the binaries and there's encryption being used and things like that is in like the IoT space or in like consoles or something, where you have to dump it live from memory. And yeah, like in those cases, XOM can be useful. Although like the main thing they bring to the table is sort of the software based one, because like hardware based execute only memory is only supported on certain architectures, notably like ARM. x86 as of yet still doesn't have hardware backing for it. Now they mentioned that they were able to do execute only on like AMD CPUs, for example, and the way that they do that is through something called user space protection keys, or PKUs. Um, I don't think they're really too well leveraged yet. But basically, it's like 16-bit tags that you can embed in the page table entries. The CPU will look that up and keep that in the TLB, and when you do an access it'll be able to check that protection key. And the idea there is you set a protection key to make it so you can't read the data, you can't do data fetches, but you can still do instruction fetches. And that's how the execute only works. It'll just it'll throw an exception if you try to do a data fetch, and the PKU blocks that.
Yeah, and
Sort of.
just to correct one thing there, you said 16-bit. It's 16 values and it's a 4-bit block, I believe.
Sorry, 4-bit,
Oh,
yeah.
yeah. A little bit bigger. Would be actually for some of the tagging aspects could actually be interesting if it was that big.
For sure. Yeah, I got the search space and the bits confused. So yeah, good correction. But yeah, what's notable there though is the kernel cannot be really bound by this sort of execute only protection, because it's in the page tables, right? So if somebody compromises the kernel, they can overwrite the page table entries, disable it, and it's kind of like over at that point. So it can only really enforce it on the user space, which, like I said, in the cases where it's used, it might be useful. There are still techniques to get around execute only memory. Notably, you can like side channel them, side channel the gadgets, which is kind of what we've been doing on PS5 actually, for certain gadgets that we've needed. Um, Unless you have like a kernel or a hypervisor bypass or something like that, but that's kind of specific to PS5. Where you don't have a hypervisor, yeah, I mean this execute only stuff, it's not really going to be able to enforce it on the kernel, and it can be broken for user space. In user space it might be useful, but it's only going to be useful on a very select handful of targets. Like you said, if you just have the binary, it doesn't do anything for you there. So yeah, as a whole, I think some of the mitigations are like interesting, I guess, from a technical angle. It is kind of cool to see PKUs being used in that way. Like I said, I don't think they're really being leveraged anywhere else. It's kind of like a newer technology that's just not really been taken advantage of. But on the security front, I don't think these mitigations are really doing very much. And that seems to be kind of the common sentiment among the people that I follow in the security community. A lot of people saying like, these are kind of like iOS and XNU has been doing some of this stuff for years, and it really didn't put much of a roadblock in exploit chains. It maybe makes it slightly more annoying. That's about it. So yeah, I mean,
Yeah.
OpenBSD has always been kind of interested in trying to be on the cutting edge of the exploit front. That's kind of been their selling point, I guess. In reality, I've never actually seen somebody use OpenBSD, but that is what they're interested in. I kind of respect the effort. I think some of the research they do is interesting, but yeah, for the most part, like especially when you compare it to like what Apple's been doing, it's really not on the cutting edge, really.
Yeah, and so yesterday when we were kind of talking about this, you brought up a page that had some comments from people about like OpenBSD security and stuff. And one of them was a comment just about these mitigations kind of being boomer mitigations. And I had never heard of mitigation being referred to as a boomer mitigation before, but it makes sense in this case. Like, when it comes down to it, a lot of these mitigations are kind of following in the trend of fairly old, of like the old school mitigations like NX, where you already have the exploit. Like the exploit is land, and then these mitigations start kind of making exploitation more difficult. And I feel like a lot of more modern mitigations, what they'll do is they'll focus more on preventing the vulnerability from happening in the first place.
Okay,
And so
not
like
not so much the vulnerability, but the primitives
yeah,
that you would
sorry,
gain from the
primitives.
vulnerability.
Yeah, like blocking certain reads from being able to happen to go out of bounds or whatever. Like with Pack or something where you need kind of more work on that. Like they happen a lot earlier in the chain. And so they're kind of able to block more, like the KLog type we were talking about a few weeks back or several weeks back. Things like that would just happen so much later, I guess, or sorry, so much earlier, and thus have a much greater impact than I think these things will, where you're just left with so much room to try and get around them.
Yeah, these I would basically throw in the post-exploit mitigation bucket. And it's kind of been shown over the years that that hasn't really worked. Like you said, the approach that Apple is taking with trying to hit those initial primitives and not once you already have like arbitrary read write and stuff. Like it's just kind of a fool's errand to try to mitigate once you already have those God mode type primitives. It Apple's kind of showing the effectiveness of hitting those exploit chains a lot earlier. So QWERTY was the one that made that quote. I brought up the link, but um, yeah, I think he's right. It's kind of like what the other players in the space were already doing like 5 or 6 years ago.
Yeah, like I
Um,
said, I think Windows has had at least that once. I don't think the stack pivoting is like that does feel a little bit novel, and XOM like XOM is still relatively new. We haven't really seen on like Windows, Linux, Android. Is it on iOS? I feel
I'm
like
not sure.
iOS has it for kernel, like trying to block
Yeah,
that.
I'm trying to think. I know it can have it because it's ARM64. I'm not sure if they leverage it.
Yeah,
Um,
so I wouldn't
I
agree
don't
that's like
remember.
what everybody's done 5 years ago. Um, it's just like the thought process behind these mitigations does feel somewhat dated. Like it feels like the wrong place to be putting your effort into.
Yeah. Current exploit mentioned. Meanwhile, FreeBSD doesn't have KSLR. It does now. The earlier versions of it didn't. So like I will say, OpenBSD with comparison to its BSD friends like NetBSD and FreeBSD is a good deal better than well, yeah, like OpenBSD is a good deal better than FreeBSD and NetBSD on the security front. But when you start comparing it to operating systems outside of the BSD ecosystem, it starts to I guess, lose some of its value, so to speak.
And I guess in fairness, with these mitigations, like they are, because we are kind of hating on them a bit here, they are fairly small in the sense of like they have a reasonably small footprint. So I guess when I'm saying that, I'm thinking about the last two: stack protection to prevent pivoting and the execution. They don't block a lot. They do up the, I guess, up the ante a little bit. They do make it a little bit more difficult, a little bit more effort. Nothing that can't be done, but they do add that. They don't take a lot of checks. So I could see I could see if Windows isn't already doing them. Like I said, I think Windows does do the one at least. And Linux, like I could imagine them implementing these just because they are pretty lightweight, but they're not that meaningful. I guess Linux doesn't really like to do those things though, so maybe just Windows, because Windows does kind of like those random little late stage mitigations too.
Yeah, Linus is kind of funny when it comes to the security front. For those that aren't familiar with his opinions, he's not very acclimable to the security industry. He really doesn't like adding in mitigations that only benefit security, especially if they have any like impact on performance. He's really like against it. So yeah, I don't think we'll be seeing these kinds of things being adopted into Linux. Maybe they will be adopted into some other Unix based operating systems. But yeah, it's not going to like it's not on the level of like MTE or something on your exploit strategies. It's mainly just you're going to have to adapt your chain a little bit potentially. It's not going to kill it for the most part. So yeah, like I said though, as much as we have been, kind of negative on the mitigations in terms of they're not going to do very much, the technical aspects of how they work and what they're trying to leverage is sort of interesting to see still. So might be worth checking out the slides for that, kind of seeing because they go into detail on like how the PKUs work and such stuff like that. I think that stuff is interesting, even if the mitigations themselves aren't earth shattering or whatever.
Yeah, and actually, just reading these comments here, Seguza has one here. It's all good, bro. They can't read libc text. They can't find ROP gadgets, which is a great point. Like, most people are going to be able to get the libc binary regardless and be able to find their gadgets from there without necessarily leaking them dynamically. Like, the XOM stuff is really just. It's only in a few pretty niche scenarios where it really matters.
It's more of a security through obscurity mechanism, in my view. Um, that's pretty much all it is. So yeah.
Yeah, I suppose. I won't fight you on that.
Yeah. All right. That's pretty much everything on OpenBSD. We do have one shout out to go into, and it's from Open Security Training, which I think we've shouted out a few times before, especially where they revamped and launched OST2. There's been some cool courses coming out of there, and it seems like one more course has just launched last week, specifically on Vuln research. So Z, you noticed this one, so I'll let you get into it, and then we'll wrap up the show.
Yeah, and so this is kind of a continuation. They have Vuln 1001 also, which goes into like your heap and your stack overflows and kind of your basic things there. And then this course looks at uninitialized data, race conditions, use after free, type confusion, and information disclosures. So some more complex vulnerability classes. The main thing here is it's not about exploitation, it is about vulnerabilities. It is about understanding the code that led to these, but they do have a couple of exploit walkthroughs. But generally, this is about understanding the vulnerabilities, which is, in my opinion, like once you kind of understand the core of memory corruptions, like most introductory things will take you through your stack-based overflow and get you into like ROP and stuff. Once you get there, I think the next important step is to start understanding all these different vulnerability classes, because most introductory things aren't talking about use after free, aren't talking about race conditions, introducing various vulnerabilities. All they're talking about is the exploitation side. So I think this is kind of a really important step. So I'm excited to see yet another course where they're covering quite a few vulnerabilities here. They covered quite a few in the first one too. So seeing more of that. That said, side note, they call type confusion tyco. I have never seen that I'm not sure what he'd call kind of making that word out of it, but I've never
Abbreviation.
seen it
Yeah.
uh, created like that and called Tycho before. Like if somebody told me, yeah, I found a Tycho in whatever, I would have no idea what they were talking about. But
That's
yeah,
a bit of a funny
I
one.
thought it was interesting to see the course here. Malware guy mentions he sounded pretty defeated there. I mean, I just would like more time to think about it before I really said, oh yeah, this is just security by obscurity. And I don't have the time to do that right now.
Well, to be clear, I was only talking about like exotext there.
Yeah,
And in my like, I think that's a fair opinion to have. I've had to deal with it on PS5, and it really hasn't been super annoying. It has been a bit more annoying on the kernel side of things, I guess. But again, like I think it does fall into security through obscurity because it's just hiding the code. That's all it's really doing. So,
but like, is ASLR security by obscurity? It's just moving the gadgets.
well, Well, no, because the address has a tangible, like needing the address is a tangible thing. Whereas once you have the binary, it doesn't impact exploitation at all. It just prevents you from your initial like research, I guess.
Needing the
It's
binaries tangible? Like it's I don't know. I mean, it's not a very
like
strong
here's how
mitigation.
I'd put it. ASLR, you would have to actively bypass it in your exploit chain. Like it requires another step in your exploit chain. Exotext, once you have the text, it doesn't matter. You can just run your exploit regardless. You don't have to dynamically deal with it, you know?
Yeah, no,
That's
fair.
kind of where
That is a
I'd go
good
with it.
distinction. And actually, Rudimal mentions you had this combo once, and yeah, this does feel kind of familiar to me, and I'm pretty sure you won it last time we discussed it. So, no, it's a fair point, and yeah, I mean, it is in a sense security by obscurity.
Yeah. Sorry, but I kind of took away, I guess, from the open security training thing, but
I mean, I moved us off onto that too. I don't know if you have anything to add about this. I haven't been through the course, but it's great to see them putting this out. Like, it is good information. I haven't had anything else to really recommend people for that middle ground. This is starting to fill that gap.
yeah, it certainly intrigues me. I was looking through some of the vulnerabilities because they link off to example vulnerabilities that they're going to cover in the course, and I was interested in how diverse the targets were because you have like some Linux kernel bugs, you have some Windows bugs, there's even like a Radare bug or two in there. A lot of diversity among the targets, which had me a little bit concerned that it might be a little difficult to follow. That said, they are talking on the Vuln research side of things, not the exploitation side. Like I think they say somewhere that they stop short, like just short of exploitation, which is where the target differences and nuances start to matter a lot more. For the initial vulnerabilities, though, yeah, I think that's actually a benefit. Looking at all these different kinds of targets and kind of highlighting that the same sorts of issues can exist in vastly different types of software. From like a disassembler to a kernel. You kind of have to deal with the same types of problems in the memory corruption space. So it looks pretty interesting. I might go through some of the course and check it out because I've taken some OST stuff before, like not taken it literally in in person, but I've went through some of their content before, and I've generally liked that stuff, especially what Neokova puts out, which I think this is his course. So yeah, I think it's a fair recommendation, even though we haven't checked it out. They have a pretty good track record with the courses they've put out, and yeah, like you said, it's an area that's not really being covered super well, at least not recently. A lot of the stuff that talks about Vuln research and these classes of issues are from like 10 or 20 years ago, not from the last couple of years. So I think it's a
Yeah,
good resource to put out.
the other side of it is like a lot of the resources that talk about these sorts of vulnerabilities tend to talk about it from a bit more of the secure coding perspective, which you can learn from it, but it is different also from just spotting it in code. Because, I mean, when you get into the secure coding, it's also about the architecture, which, as a Vuln researcher, you don't have control over how you're going to architect something. So, like, those sorts of lessons they have value, but they're not as valuable. So yeah, I mean, I was excited to see the course. I'm hoping this means soon we'll get one of their actual exploitation courses. Because I know for years I recommended from like the first OST, their introduction to software exploitation course. And that's kind of bit rotted now because that was put out back in like 2010 or so. Uh, but yeah, I mean, I'm just happy actually to see new content from OST too, because they were gone for quite a while.
XCD80 mentioned when I go to that page it says enrollment is closed. Are you logged in? Because I think that's something I've encountered before on some other courses where it was just a case where I wasn't logged in, and then once I signed into the site, it let me go into it. Not
Yeah,
saying
I
that's necessarily a
don't.
course here, case here, but I think it might be.
Yeah, actually, I am kind of disappointed here that. So I do actually see now. Okay, so I'm logged in another browser, sorry, and it says classes start July 16th, 2023. So while we're looking at this, I see classes start March 24th, but when I'm logged in, July 16th, and enrollment is currently closed. So
Ah, okay.
I I think so. I
We
mean, it
got
was.
bamboozled.
Yeah, and I mean they posted this on Reddit saying like we put this course out today. So the fact that you can't enroll is actually really surprising. I guess I should have tried that. It's disappointing that you can't, especially because they announced this thing out there. I wonder what's up with that and why there's that delta. Maybe it's just a bug in the site or something. I'm going to hope that's the case because that kind of sucks.
Yeah, maybe I'll reach just shoot a message over to Neokova on Twitter or something and see if it's just a bug. Because especially where it was announced, I could see it just being some bug in the site. So yeah, hopefully it's accessible soon though. Basically, because it seems like a cool course. So yeah,
Clearly, a
and
lot of
malware
work put
guys.
into it.
Yeah. And Malware Guy said OST2 is definitely good. I'd recommend them too. Yeah, I think they do have like a plan for some future courses and stuff and trying to get some other trainers involved with it. Um, yeah, I've always kind of repped them because it's nice to see the free trainings being offered on some of that stuff. Because for so long, a lot of the decent-ish trainings for VR and exploit dev are like $6,000 or $7,000 SANS courses or something. Like it really sucks for somebody who wants to jump in and the only sort of resource you can recommend is not accessible to them unless they can get a company to pay for it or something like that. So yeah.
Yeah, it's definitely disappointing. And yeah, I pulled up their roadmap here, which shows that they're like currently in progress on their exploitation courses, but we don't have them out yet. Although this thing also says that Vulnerabilities 1001 is in progress, so maybe
Might
not
be a little
quite so
outdated.
up to date.
Yeah. All right. But
Nonetheless, lots of good content here. I don't like they make you register and everything and enroll before you get access to it, but it's still
it's
solid
not a huge
content.
ask, so yeah.
No, it's not.
All right, so yeah, that's all the topics that we have for today. So thanks goes out to everyone who tuned in, and especially those that have been with us for those 200 episodes. If you want to catch those past episodes, you can find recent ones on Twitch and all of them on YouTube, Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat as well. And yeah, we'll see you next week.